Welcome to United Astronomy Clubs of New Jersey. And this is how to contact us by accessing the address below, www.uacnj.org. Also on our site, you might want to find out information about astronomy for kids. I'm making the presentation, Karl Hricko, former president of the Amateur Astronomers Incorporated, and also former president of the UACNJ, and also starting the National Space Society New Jersey chapter, Space and Astronomy Society of Northwest Jersey. Here's how to contact us. On Astra is our motto, to the stars. You can become a member of the National Space Society and or become a member of our local New Jersey Society or chapter of the NSS. Contact us by the Facebook address below, and you can become a member with no charge if you join the New Jersey chapter, but you have to pay if you join the parent organization, National Space Society. But you can join us and not pay and not be obligated to do too much, but just to keep in contact to find out what's going on in space. The presentation is a virtual tour of our universe. And that image in the middle is the Andromeda Galaxy, M51, with two satellite galaxies next to it that it's drawing in, cannibalizing. Now let's go on a tour. As we tour, we'll go to the moon, we'll visit stars, go beyond the stars to the galaxies. Let's start to the moon first. The moon really has two different sides, the front and the back. Now, all sides of the moon are lit at all times, but we only see one side. Near side, we don't see the far side on the right. Near side left, you can see a lot of dark patches, more than likely produced by impact objects like asteroids and meteors and things of that nature, producing these craters, which are then filled in by underlying melted rock, producing rock structure that didn't really reflect that much sunlight. You can see the difference then. The side facing us, dark patches, which we'll call seas by Galileo, who thought they were bodies of water, but they're not. And on the right would be the other side. Notice that there's a difference. Mystery about that. Hardly any kind of dark patches, and also it has more density on the other side. It's thought that some object about the size of Mars hit the Earth in the past when the Earth was forming and chipped off about two pieces. One piece joined with the other, making the moon. The side that joined was denser, and so the back side is denser than the near side. Let's go to the moon. Have we been to the moon? Well, let's find out. We didn't go this way, however. We went in 1969. We went in this spacecraft, the upper spacecraft, the Apollo. The program started out with the bottom spacecraft, the Mercury, one astronaut, then graduated to the Gemini, two astronauts in the middle, and then finally the Apollo, which went to the moon. On the left are the different size rockets that took each individual spacecraft up. Far left, of course, was the largest one, the Saturn, that took us to the three astronauts that went to the moon, starting left, right. Left, Neil Armstrong, middle, Michael Collins on the right, Edwin or Buzz Aldrin. Only two of them walked on the moon, left and right, Armstrong and Aldrin. Collins stayed on board the orbiting service and command module of the spacecraft, while the two others went to the surface of the moon on the lunar module. Here's the Saturn taking off. On one of the trips prior to this, image was taken of Earthrise coming up above the surface of the moon. Fantastic image of Earthrise. Later on, image taken of the lunar module descending to the moon with the 2 astronauts on board. Landing on the moon, the Eagle has landed, stepping off the ladder of the lunar module. An image of Buzz Aldrin. Neil Armstrong stepped off first. He had the camera. Then he took the picture of Aldrin stepping off the moon. Then he exchanged the camera with Aldrin. And Aldrin took the picture of Neil Armstrong, finally. In the visor, you can see Spielberg on his director chair, taking this image in Area 51. Not really, no, we've been to the moon, been there 6 times, 2 astronauts each, 12 astronauts landing on the moon. So far, only America has done that. Later on, in about the 4th Apollo program, the first one was 11, number 11. About the 4th one, Apollo 14, they took on board a moon buggy, a rover, on which they rode around the surface of the moon. Not very fast, but comfortably enough. They planted the flag on the moon. And the flag seems to be flying, although there's no atmosphere on the moon, no wind. Actually, what they did is they put some kind of wires in the flag to make it stand out to take the photo. They planted various kinds of instrumentation on the moon, mirror to reflect back a laser that we could shine on that mirror on the moon to find out how far away it is more precisely. And we find out too that the moon is moving further and further away from us, about an inch a year. So these instruments were planted. Later, after things were completed on the moon, the longest stay on the moon was the last one, Apollo 17, about 3 days on the moon. Returned back to the lunar module. There's a leg of it there. Boarded the lunar module. It departed by launching from a platform. So there should be 6 platforms left on the moon, besides the footprints, the flags, and also instrumentation. The last 3 astronauts on the moon were Schmidt, Harrison Schmidt, Ron Evans, to the right, and below, Eugene Cernan. Eugene Cernan was the last human on the moon, Apollo 17. Now we're going beyond, going to the whirling planets. Here they are. How many of them are there? Well, there used to be 9. Now there's 8. Pluto has been designated as not a bona fide planet, but being a dwarf planet, also called a Kuiper Belt object. Talk about that later. KBO. We'll look at the sun around which the planets circulate. The sun does not burn, not enough oxygen, but it does produce energy and particles by the process of fusion, combining hydrogen with hydrogen to produce helium. That's where all the energy comes from. So it's not burning. So this is our brightest star, our daytime star, actually. And by the way, it's being classified now as a dwarf yellow star, interestingly enough. Looking at the surface of the sun, we can see the plasma jets shooting off of the surface following magnetic lines. that are part of the sun's structure itself. These will shoot off, come in our direction sometimes, and cause various kinds of problems with our communication, our electrical grid, and also our orbiting satellites. Oh, by the way, they also produce northern and southern lights, which are the beautiful parts of the sun's effect on us besides heat and light. And here is an image of a sunspot on the sun with magnetic lines shooting out of it. Where a magnetic line comes out of the sun, it produces a sunspot. Where it goes back in again, in a loop, it produces another sunspot. So they normally appear in pairs. So you can see that the sun produces light and heat for the planets that circle it. And that makes up our solar system. Here is a beautiful image put together of the various planets, starting from left to right. Sun on the left, and then we start with the planets. We have the planets being Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Can't see Pluto. I guess we eliminated Pluto. But here we have the 8 planets, official planets. And in between Mars and Jupiter should be the asteroid belt. And we can remember this by remembering the sentence, "My very energetic mother just served us nachos." If we include Pluto, we can say, not nachos, but no pizza, something of that nature. Now we have the first planet from the sun, Mercury. It's the fastest and the closest planet to the sun. It's not the hottest, though. Matter of fact, it has water on it, ice, hidden in craters away from the sunlight. Has no moons, no atmosphere that can be spoken about. Next planet, Venus. It is a beautiful ringed planet. It's the hottest planet because of its atmosphere of carbon dioxide, producing a greenhouse effect. Also has an atmosphere that contains sulfuric acid. It rains sulfuric acid. Not a good place for timeshare. No moons going around Venus. Also called, by the way, Venus also called our twin planet. It has the same size as the Earth. Here, of course, is our planet, the only one known to have life so far, at any rate. Here's our mother planet. And the next planet rising here is the red planet. Red because it has rocks made mostly of iron, and so they rust. This is a rusty old planet. Venus. And, it's about, let's see, 1/2 the size of the Earth, and it has about 1/3 of the gravity of the Earth itself. So living on Mars will not be the same, although Now, Mars has always been the mystery planet, and as a result, there's been a lot of writing in science fiction and movie making, on radio programs, whatever it might be, about the Martians, and they seem to always be attacking us for some reason or other. NASA had a flyby and took an image of an area on Mars, came up with this photo. What does that look like? Let's take a close... Why, it looks like maybe a face on Mars. At first they thought it might be a monument left over by the Martians that may have lived there at one time. But then NASA sent up another probe. That probe went around Mars, took this picture again, higher resolution, and it turns out being just a geological feature of sorts. So it's not really a monument on Mars, although some people still think it might be so. Now we've got a meteorite that came from Mars, kicked off Mars, got into orbit around us, and finally came down in the Antarctic region. We picked it up, we sliced it open, looked at it through an electroscope, and lo and behold, we have this image. It looks like there's some kind of biological symmetrical images, objects in here looking like worms or maybe even small bacteria called nanobacteria. That might be the case, and the team that came up with this, team of scientists, characterized it as possibly fossils on Mars, but that has not been verified up to this point, and so it's still a question. The next planet. Jupiter. Jupiter, our largest planet. All the gas giants, including Jupiter, have atmospheres of methane, ammonia, water vapor, hydrogen, and some traces of nitrogen as well. The center has a core that's squeezed so close together that it acts like a metallic core. Now, Jupiter has, at this point, 79 moons around Jupiter. And if we look further, we can see a spot, a red spot, or sometimes taking on a different color. This way looking cream or maybe some kind of off color between the two. It's as look how large it is compared to the Earth lower left. Quite large. It's a hurricane type of storm on Jupiter, which occurs over and over again and has lasted for a while. And the largest moons of Jupiter were spotted by Galileo through his small telescope in the 1600s. He characterized them as stars at first, but then later on he realized they were moons, named after him, the Galilean moons, and now have individual names from upper to lower: Io, Europa, Ganymede, Callisto. Remembering it by saying, I enjoy good coffee. The beautiful ringed planet, Saturn, coming into view. Here it is, Saturn, the ring of beauty. Oh, by the way, forgot to mention, let me go back to Saturn, what I'm talking about now. Saturn has over 100 plus moons in its, including moons in its ringlets. Officially named, it has 62 moons, but there's a lot in its ringlets. And the next planet, as you see over here, after Saturn, Uranus. Hard to see its surface because it has an atmosphere, including a lot of nitrogen, which kind of blocks the surface from view, as you see here. Uranus has 27 moons, same atmosphere as all the gas giants. And now the year is becoming longer and longer on each of these planets as we go further and further away from the sun, because they're going slower and slower. Now Uranus is the only planet that's rotating on its side. How about that? Been tipped over by something. And so in a direction of its orbital motion, it's spinning on its side. Next planet, Neptune. Has a bluish appearance. Again, same type of atmosphere as the gas giants. Neptune has 14 moons going around it. And again, it's going slower, so its year is longer. It has the highest winds, over 1,000 miles per hour. Now, what about Pluto? Is it a planet? Well, it's been reclassified. It's been reclassified as a dwarf planet, or as I mentioned before, a Kuiper Belt object, KBO, or a trans-Neptunian object. And by the way, it has 5 moons around it, interestingly enough. Hasn't been classified as a planet at this point because, number one, it hasn't cleared its orbit of all the debris that might be in the orbit. It has the other 2 necessary kind of criteria. It is spherical, hydrostatic equilibrium, and also it orbits the sun, but it hasn't cleared its orbital path. Tiniest of the planets, the longest year. It has water on it as well, hidden in those craters. So let's look at our solar system compared to the sun. Look at those sizes. Amazing comparison. Now, every so often we have these wispy objects coming through. These wispy objects are called comets, and the comets essentially are thought 2 areas. A nearby area just beyond Neptune, in the upper image you can see, called the Kuiper Belt. A lot of objects are in this area, including Pluto, which is why also it's been classified as a Kuiper Belt object or a dwarf planet. Now that's about 30 or 40 astronomical units from the sun. An astronomical unit is the distance between us and the sun, so we're talking 93 million miles. 30 times 93 million miles is how far these objects are in the Kuiper Belt. Further on out is another region which contains similar type of objects that become comets if they're pulled in toward the sun and wind up with a tail. It's called the Oort cloud. You can see the blue pointer pointing to the Kuiper Belt going around the sun, and then the larger spherical area making up objects of the Oort cloud. Comets coming from the Oort cloud take a longer time, so they're long-term kinds of comets. Now, a comet is made of 2 tails. One tail is yellowish, which is a dust tail that follows the path of the orbit of the comet around the sun, and the other tail is a bluish, which is plasma tail or ion, and that follows the magnetic fields of the sun. So sometimes you can see 2 separate tails in a comet. Now, when we pass through the remains of the tail of the comet, which we do, we wind up with the particles in that tail coming through our atmosphere, burning up. These are small little dust particles burning up and producing what we call a meteor shower. So most of that meteor shower is made of particles that are very tiny. Every so often there's a larger chunk, but mostly these tiny particles, and they occur maybe once or even twice a month, these meteors. Larger pieces, meteors, come from asteroids that break up. These chunks come to the Earth in larger structures, which we call meteors. Then, depending upon what kind of asteroid they come from, they might be either stony or metallic, or a combination of the 2, or even having carbon, depending upon the asteroid they came from. These are the categories of the different types of meteors. Every so often, an object comes in that explodes in the atmosphere like an atomic bomb and will cause problems on the surface of the Earth. This happened in 1908, when it's believed that some kind of large possible comet or asteroid exploded above the surface of the Earth and shattered an area of trees in Tunguska, Siberia. Something of this nature. So we do have these things occurring on Earth, impacts. Another one, the meteor crater, Flagstaff, Arizona, sometimes called the Barringer crater or the Arizona crater. You can see information about it. This happened, about 74,000 years ago, so before humans were here. And it's about about a mile wide and a lot less than a half mile deep. Let's continue further and go out beyond our solar system into where the stars are. And we're going to be looking at areas where stars are just forming. This is the Orion Nebula in Orion constellation, a nursery for stars. Another one, also in Orion. This is, as you look, you might see an image of what might appear to be a horse head. So it's called the Horsehead Nebula, or whatever image you can conjure up in your imagination. Maybe, I don't know, the Loch Ness Monster or a dragon or something of that nature. Beautiful image, only seen through telescopes, however. Star formation area. Here's a famous one taken by the Hubble. Look at this. This is called the towers of creation. Each tower contains masses of dust and gas in which new stars are being formed and being popped off like different sorts of spores coming out of those towers of dust and gas, hydrogen gas. Star formation area, nursery for stars. These are actually the claws of the Eagle Nebula. Now, stars also die. They have a lifetime. When they die, they produce this kind of image, which is a nebula again of dust and gas coming from the star that has given off this gas, either by explosions or just puffing them off. This is the Rosetta Nebula. Now we're going to become this kind of nebula when our star, the Sun, does this in about 5 billion years. Another one, the Crab Nebula in Taurus the Bull constellation, in the center of which is a neutron star spinning rapidly, so it's being categorized as a pulsar as well. We can also pass by and view these globs of stars called globular clusters. Many stars all together like a beehive, moving like bees in a beehive all around. Beautiful image. There's other types of clusters as well. Here's the Pleiades, an open cluster of stars. New stars, by the way. Blue stars are new stars. Red stars are old stars. We go further on out, image of our beautiful Milky Way. Now, nothing has gone out this far in a way of a probe, but if you sort of imagine we're located at the fringe areas, the ends of our galaxy. Our sun is at the suburbs, in the suburbs of the galaxy. We can take a picture inward, and as we do, we can see this. And so we're taking a picture from our sun at the edge of the galaxy looking inward. This is how our galaxy would look to some kind of traveler in space coming into our galaxy. Beautiful, beautiful image. Spiral galaxy on edge. Also in space are these galaxies that are being drawn in by gravitational attraction, being cannibalized by other galaxies, making them larger. This is a common thing. Matter of fact, the Andromeda Galaxy, M51 you see here, has these satellite galaxies surrounding it, one on the upper portion, one in a lower image. Both of these are being drawn into the Andromeda, which is becoming larger and larger by cannibalizing other galaxies nearby. We're being drawn to the Andromeda Galaxy like a tractor beam. Our sun, all the planets. We're supposed to get there in about 5 billion years. set your watches. Now, in these galaxies, and also in our own galaxy, are extrasolar planets, planets going around other stars. We've spotted the shadow of these stars cutting across the surface of the star, blocking out the light enough so we can capture that dimming of the image. And as we do so, we can locate them. Some of them go around double stars, as you see over here in this artist rendition of an extrasolar planet. Another extrasolar planet, artist image, how it might be. Now, have you been in space? Well, we have the International Space Station. We're living in space. Although it's low Earth orbit, still, it's in space. And the astronauts, of course, are in a condition of weightlessness. Now, they do have weight. They're falling toward the Earth with the space station itself. But as it falls to the Earth, its curvature fits the curvature of the Earth, and so it stays in orbit. So, while they're constantly falling toward the Earth, they're really orbiting it because as they curve toward the Earth curves away from it. We've gone there in our shuttle, but it's no longer operational. We have to use Russian rockets to go to the space station at this point, although SpaceX is setting up and organizing some kind of travel to the space station in the future, not too far in the future. And these are some of the spacecraft that will be used in the future to go to near-Earth orbit, and also maybe to take passengers into space. You might even have orbiting hotels around the Earth from which to travel on a side trip to a trip around the moon, possibly. Interesting things of the future. Well, can we go to the moon? Well, we plan to go to the moon in the next few years, as a matter of fact. Let's see what happens. When we get to the moon, we plan to set up a outpost, colony, then a settlement on the moon, using the material there to construct some of the habitats that we'll be living in on the moon itself. The moon has 1/6 the gravity of the Earth. Divide your weight by 6. That's how much you'll weigh on the moon. Now, there's all kinds of issues on the moon. We have to be concerned in protecting ourselves against radiation. We also have to think about that low gravity and work within the context of that low gravity. And we also have to consider the incoming objects, impacts of small meteors and things like that. So it might be best to construct habitats below the surface later on to protect ourselves against all these different kinds of hazards we'll have on the moon. But it is possible, and we intend to do so. Besides the moon, where next? Let's launch off. Go to Mars. Now, the gravity on Mars is 1/3 the gravity of the Earth. Got the same problems on Mars as the moon. Got incoming meteorites and things of that sort. We have radiation because the atmosphere is a very thin atmosphere of carbon dioxide. One of the ideas is Mars One, which has been launched by a company out in the Netherlands, asking for volunteers to go on a one-way trip to Mars. One-way trip. And people are volunteering for it. They intend to send these modules up, about 6 of them, carrying 4 people each. So there'll be 24 people landing on it, on these habitats, living there, until they're able to other habitats to extend living conditions on Mars. And again, live off the land, construct some of the things they'll need on Mars from whatever material is there. Do some mining on Mars, set up a colony, settlement possibly on Mars. Here's mining going on in artist's rendition. You can see them working on Mars. And we also have the two moons of Mars, Deimos and Phobos, which are thought to be captured asteroids from the asteroid belt between Mars and Jupiter. We can mine those as well, gather minerals from them, and utilize that. Now, can we go further beyond our solar system, out to the stars? Well, that would require other kinds of energy, maybe nuclear energy, and possibly a trip on a spacecraft that would last hundreds of years. So the first generation, second, third, maybe even fourth, may not get there. They'll live and die on board the spacecraft itself. Finally, maybe the fifth or sixth generation will get to one of the exoplanets around the stars to see what it's like. These are ways of traveling. Another way might be warp speed. Maybe go hyperspeed, a la Star Trek, Star Wars, whatever the case might be. Science fiction now, but possible reality in the future. We could do that by looking for black holes within the center of other galaxies. That would take a while, obviously. Here's a black hole on its rendition. Look inside that black hole. There it is. And the black hole, we think, consists of a horizon called the event horizon. You pass through the event horizon, and in the center of the black hole, what makes the black hole is something large, a large mass that has collapsed into a very tiny point called a singularity, maybe star or group of stars coming together. That's part of the black hole, the singularity, causing space to be compressed such that there's a tremendous large force of gravity at that point, though. At that point. Not a large amount of gravity, larger than the mass of the object that collapsed, but the large amount of gravity near that singularity. Now, as you pass through, you might wind up in another area that might be connected to the black hole, past the singularity. And it might be something connecting two parts of our universe at different places or at different times, or possibly two different universes. So there might be a connection between the two, and it might involve what's known as a wormhole that connects these two black holes, matter entering into the black hole and coming out of another black hole, which you might call a white hole, because matter is exiting into another part of the universe, time, or another universe. Might enter a black hole, another type. And if we enter the black hole through its bulging side, the ergosphere, we might be able to pass through, as you see the astronaut on the left. Or, if we don't, we'll be drawn out like a piece of spaghetti noodle, spaghettified, not making it through at all. But if we do pass through, we might see this artist conception of what it might be like in a different part of the universe, or at a different time, or a different universe. Now, if we pass through certain black holes, we might be a bit cautious, because as we pass through the black hole, we don't want to wind up seeing something like this. We don't want to see this. Now, we have to travel, we might want to travel, through something like this spacecraft, which has been successful, at least in science fiction anyway, and we might want to speak to people who have been on trips like this to find out more information about how it can be done. Here's one crew that we're familiar with, I'm sure. Another crew. And still another. And as we go on, we have some more. And another. And finally the last crew. So far anyway, I think it's the last crew. Or we can speak to someone who is major guru in science fiction. Maybe he will tell us how to do it. Or even after, we can ask how to get there. How do we get to these places? We know how to get there, but how do we get there? He'll point the way to us. How to get to the stars, ad astra. Now we're going back to Earth. Here we are looking up at the, wow, I wish I could see a place like that from the Earth. Look at that, looking up at the sky, seeing galaxies and stars as you go hiking in a higher area or any place that is a dark sky sight. And as we're there, we can appreciate our beautiful world. And this could be you on Mars, the moon, wherever a colony or a settlement might be set up. That's our trip, the end of our tour, and hope you enjoyed it. Again, we are the UACNJ, and you can also be a member of National Space Society chapter in New Jersey, Space and Astronomy Society of Northwest Jersey. We're just contacting me, Facebook below, or UACNJ. And I thank you for watching this PowerPoint presentation, and I hope you join us in the future as it becomes available to visit us at Jenny Jump Observatory, and we'll see you next time. Bye.